Okay, hi everyone. Today we're gonna put what we did last time into practice. We're gonna draw our vertical asymptotes and horizontal asymptotes, as well as looking at some key values such as the X-intercepts. And the problem here is given as 2x squared plus 2x minus 8, or 2 times the fraction x squared plus 2x minus 8 divided by x squared minus 9. So that's my original problem, but these problems are going to also factor it for you. So they did most of the work for you. They factored it for you. So for this problem here, let's go ahead and look at some characteristics here. So for this problem, I want you guys to make note is that if I multiply this in, okay, multiply that in, this is going to be 2x squared plus 4x minus 16, sorry, 16, all over x squared minus 9. Now please note that this 2 in the front, it's not 2 to the top and 2 to the bottom. Nope, nope, nope. It's just 2 to the top because it's invisible 2 over 1. So please be aware that's just 2 over 1, and that's going to be a big deal later. Now, we had a couple of things that we went through, a couple of steps, but let's look at what the question is. It says draw the x-intercepts first, then draw the vertical asymptotes, and then followed by the horizontal asymptotes. So we're going to draw 3 characteristics of this graph without almost doing any work. So the first characteristic is this. That's going to find our x-intercepts. X-intercepts are when the graph hits the ground. So what I mean is, when does the graph hit the x-axis? And we know that is by making the numerator of a fraction go to 0. When the top goes to 0, that's our x-intercept. The top goes to 0, that's our x-intercept. So for your notes, why don't we copy this? Copy 2, x minus 2, x plus 4 over x minus 3 and x plus 3. Okay, that's what you're going to copy in your notes. What numbers will make the top go to 0? Okay, and I don't care about the bottom. What numbers make the top go to 0? Hopefully you notice that 2 and negative 4 will make the numerator go to 0. If I plug in positive 2, 2 minus 2 is 0. 0 times anything will be 0. So what we're going to do is we're going to take our dot. In this graph, you're going to end up with a dot on the bottom. See this dot here? You're going to take that and you're going to dot at positive 2 and negative 4. That's it. Those are the zeros of the graph. The next part of this is we are going to draw the vertical asymptotes. Now with vertical asymptotes, do you guys remember, is that the numerator is 0 or the denominator is 0? And that's when the denominator is 0, because we can't divide by 0. So what numbers will make the denominator go 0? At 3 and negative 3. Are you guys okay with that? At 3 and negative 3. That's when the denominator would go to 0. So at 3, positive 3, we're going to draw a vertical line. And at negative 3, we're going to draw a vertical line. Now, in reality, I would have actually drawn, if this was 0, at 3, I would draw a dotted line. And at negative 3, I would draw a dotted line. But for us to practice this on My Open Math, they're asking you to draw a solid line. So you would take this feature and just draw a line, a vertical line. Okay, at 3 and negative 3. The third question is, what about horizontal asymptotes? Now, horizontal asymptotes, we had 3 possibilities. And hopefully you remember, if the top is bigger, so horizontal asymptote, if the top is bigger, if x cubed over x squared, that's a possibility. What about if it's x squared over x squared? What if it's the bottom is bigger, x squared over x cubed? These were our 3 possibilities. Is the top bigger, the bottom bigger, or are they the same? So if the top is bigger, which was rule number 3, I went in the reverse order, there is no horizontal asymptote. If the exponents are the same, we said we just copy the front numbers, which is here is 1 and 1. The horizontal asymptote, is equal to y is equal to 1. That's a horizontal asymptote because it's 1 divided by 1. It can't be that simple. It really is. And what if the bottom is bigger? The horizontal asymptote, y is equal to 0. So looking at this problem, you see 2x squared and x squared. Is this going to fit our top is bigger, the bottom is bigger, or they're exactly the same? Hopefully you notice that they're exactly the same, so we copy the front coefficients is 2 and 1. 2 divided by 1 is 2. We draw a horizontal asymptote at 2. So if you worked on these characteristics last time, this should be pretty easy for you. So let's go ahead and draw this out. We said we had a 0 at positive 2 and negative 4. We have a vertical asymptote when the denominator is 0 at positive 3 and negative 3. Oops, darn it. You have to draw 2 lines. Clear off, forget it. We said positive 2, negative 4. We said 3, 3. And at negative 3, 3. We have to draw now a horizontal line. That's direction number 3. Horizontal line at, we said 2. There you go. So if you take a look here, my answer is vertical asymptote at positive 3, vertical asymptote at negative 3, and a horizontal asymptote at positive 2. That's all you have to do. Submit question.
Can you explain why x squared over x squared is 1 again graphically?
I'm sorry. Oh, yes. Not a problem. So if I multiply this as original polynomial, we would say is 2x squared plus 4x minus 8 over x squared minus 9. So to find a horizontal asymptote, we said we look at the biggest bully here, which is our x squared. So these are exactly the same. If the exponents are the same, what is 200 divided by 100? That's just 2. What's 2,000 divided by 1,000? That's still 2. And what happens is, what about the 4x and the 8? Well, that's just a little bit of side hustle. And these side hustles, as x gets bigger, don't matter. The biggest bully matters. So it'll be 200 divided by 100 is 2. 2,000 over 1,000. If I said, hey, Mrs. Ko, what is 1,000,009 divided by 2 million? Do you even care about this 9? The point is that it's not going to be perfectly 2. It's going to be pretty close to 2. So as x goes to infinity, this graph will become 2. So the hustle is that if I can see that they're running at the same speed, we don't have to worry about the rest. We just worry about the front. And that's a 2 over invisible 1. 2 over 1 is my horizontal asymptote. Is that a little bit better?
Yeah. But it feels weird for me that I have to memorize it. That's what I'm trying to like fully understand in terms of a graph. But I think it makes sense.
So here's another way of looking at it. Remember, if I write 2,000 over 1,000, right? Do you even care about the numbers on the side? You just worry about the 2 and the 1, right? As in 2,000, 1,000. So as x gets bigger, what happens is it's just going to be like 2 million over 1 million, 2 billion over 1 million, 2 trillion over 1 million, 1 trillion. It's just going to be getting closer to 2 over 1. But if I give you another option, what if I wrote x over x squared? Who's the biggest bully here? Hey, isn't the bottom the biggest? So as x gets bigger, 10 over 100. Well, isn't this like really 0.1? What is 100 over 10,000? That's even smaller. Okay, what is 100 over, no, it's 1,000 over 1, 2, 3, 4, 5, 6. That's even smaller. So as the numbers get bigger, oops, sorry. As the number gets bigger, this gets closer to 0. And that's what we learned.
Okay, yeah, that makes sense.
If we learn like algebra 2, if I divide 1 over x, as x got bigger, this whole fraction get closer to 0. It gets smaller. And it turns out if the exponents are the same way, where the bottom exponent is bigger, follows that trend. Eventually the bottom's going to kick the butt of the top as x gets bigger. And then you end up with a smaller number. But if your top exponent is bigger, there's no bound. if I say x squared over x, even if it's like a plus 1 here, the top is going to be bigger. And as we continue to get bigger and bigger and bigger, 100 over 10, 1000 over 100, right? The top, oh sorry, this 10,000 over 100. As x gets bigger, the number shoots off. And so at the end, it's going to be no holds bar. It's not going to shrink to 0. It's going to actually go to infinity. Okay, let's try another one of these. Okay, we're going to answer the questions that they asked. They wanted 3 parts. They want to first draw the x-intercepts. So you have to know x-intercepts is when the top of the fraction goes to 0. X-intercepts is when the top of the fraction goes to 0. And the top of the fraction goes to 0 at 4 and negative 2. Right, 4 minus 4 is 0. Perfect. 4. Negative 2 plus 2 is 0. Perfect. Now we'll have some special rules later about what we call holes, but we'll discuss that next time. I want to make sure you guys can graph these first characteristics. All right, next question is finding vertical asymptotes. Vertical asymptotes are when the denominator is equal to 0. So we're at 0 at positive 3 and negative 1. So positive 3, negative 1. Last part is what's a horizontal asymptote? Since we can look up here, and in this problem, they look like they're the same, right? The top exponent and the bottom exponent are the same. So it's really 2x over 1x squared. 2x squared over 1x squared. What about the rest? You know what? As x gets bigger, these guys don't matter as much. If x was 100, do you think negative 8 is going to matter? If x was 1,000, do you think negative 8 is going to matter? If x was 1,000,000, do you think negative 8 is going to matter? No, it's not. So as x gets bigger, these become less of a vital role. So in this case, it's going to be 2 over 1 again. Now, this is the part that's helpful. I right now can with 99% certainty tell you I know how this graph looks. Let me ask you. We said the graph has to hit this point here at 4, right? So could it be up here? We would never hit the graph 4, would we? So automatically, I know the graph is going to look like that. Because we're stuck on the bottom. How about the left side? Look at the left side. Am I going to be up here? What value must we hit? We have our root, don't we? We have to hit this graph right here. Automatically, I know 2 parts of this graph. The third part, let's go ahead and plug in easy numbers. I can plug in 0, 1, or 2. Those are numbers in between. Am I going to be up here or down here? Well, first thing, I got a hint here, and this is a trick. Can anyone tell me why for sure I'm going to be up here and not down here? Can anyone think of a reason why I'm not going to be for sure down here? You know what? Let's go ahead and plug in the value and see what happens. If I plug in 0, is everyone going to zeros here? That's 0. Let's plug in 0. 2 times 0 minus 4, 0 plus 2, 0 minus 3, and 0 plus 1. So that's 2 times negative 4, 2, negative 3, and 1. This is going to be 4, 4 is 16, negative 16 over negative 3. This is positive 3 goes into 16, 5.33. You're up here. I can guarantee you with 99% certainty that that's what the graph looks like. Now, how can I do this? It's first, remember how there's only 2 zeros of this graph? There's only 2 zeros of this graph. Are we allowed to hit any of these points in between? Nope. We don't have any more zeros. So I know this graph isn't going to cross over. Also, the graph will probably not do something like that because there are no zeros. So I know I'm most likely going to be up here. That's how I know. Now I'm going to go ahead and just graph this for us just to prove a point. let's go ahead and prove a point. Oh, darn it. Nope, I lost it. Let's just prove a point. Then we're going to write a fraction x squared minus 2x minus 8. Darn it, it didn't give me the squared. Divided by x squared minus 2x minus 3. Folks, take a look at the graph we have on the right here. Does that look like the graph that we had drawn previously in our notes? We said at 0 it would have been 5.33. Yep, we have a 0 at 4 and at -2. Looking on my left hand side, 4 and -2 are going to be our zeros. This graph eventually has a horizontal asymptote of 2. Take a look here if you guys can see. See how it's 0.8? It's looking like it's tapering off around 2. By the way, it's not going above 2, right? Not going above 2. We have no zeros in the middle of the graph. Right, so all the characteristics that we demonstrate on the left side are going to be reflected on that right side. Okay, let's do another one of these problems. Let's do one more. What are the zeros of this graph? The zeros are going to be, so now I'm going to do this without any notes. I'm just going to plot in the points, answer the questions. What are the x-intercepts? Looking at this problem, when will the graph go to 0 on top? What cancels out with a -4? +4. What cancels out with a +4? -4. Those are the zeros of the graph. This is from Algebra 2 and Pre-Calc. What are the vertical asymptotes of the graph? Looking at the denominator, what would cancel out at x minus 1? If x was +1? And if x was, what cancels out x plus 3? A -3. All right, we got our vertical asymptotes. Looking at our front, -2x squared over x squared. That's going to be -2 over, because it's the same speed, x squared over x squared. So it's just -2 over 1. Take a look. That's my horizontal asymptote. Now, given these characteristics of this, if I wanted to complete the graph, I already know that this graph is going to be on top. So on top, oops, sorry, darn it, too much. It's going to be on top. It's going to be on top. See, I already know these things. Done. Do we have any zeros here? Nope, no zeros. So we're probably not going to be up here. No way, Jose. Sorry, Jose. But if I plug in a number, let's plug in a number that's say 0. Remember how 0 is a graph here? Let's plug in 0, see where we're at. If I plug in 0, 0, 0, 0, that's -2 times -4 times 4 over -1 times 3. This is going to be a positive 32 over -3. And this is going to be really negative, isn't it? So that's going to be negative 10.66. And that's way down here. So we know we're going to be on the bottom of this graph someplace. Someplace down there. So let's see if our graph is reflected in Desmos. We change the graph numbers around. This is, we said was going to be -2. The top was going to be $16. The bottom is going to be very similar to that. We're going to change that to a plus. Now, if you take a look at the graph that I drew here, pretty darn close. If I include my x-intercepts and vertical asymptotes, we said x was equal to 1. X equals to -3. Okay, those are bounding my graphs. And we also said my horizontal asymptote y is equal to -2. Oops. I'm going to change some settings here real quick. Change the color. Call this, call them all blue. Blue and dots. Blue and dots. Blue and dots. Okay, and you can see the vertical asymptotes and the horizontal asymptotes taking form. Whoa, this one actually crossed. Whoa. Would not have guessed that. And -2, ooh. No worries. Okay. Now let's look at this next question here. This problem here, you guys are gonna graph this using the rules that we talked about already. They said first place the horizontal and then place the vertical asymptote and then plot additional points on the graph. So before we start this, I want to make sure we know what our vertical and our horizontal asymptote is, and we're going to pick a point to make it easy. So let's look at the problem. I want to factor it out. 2x plus 3 over -2x plus 1. Take a look here. I factored out a 2 from both of them. So we see it's -1. Okay. And we're left with x plus 3 over x plus 1. So please first tell me, what is a root in this problem? Are there any zeros on top? If x is -3, let's write this as a point. Sorry. If x is -3, y is 0. So I plug in -3, -1, 2, 3. We have a 0 point right there. Okay, everyone okay with that? -3, 0. Vertical asymptote. What number would make this go to 0 on the bottom? -1. So we have vertical asymptote at -1 way over here. We have a horizontal asymptote. Looking at my original function, would these be the top is bigger, the bottom is bigger, or they would be at the same speed? Yes, Nazareth, I'm going to be uploading it today. They're the same speed because they both have the exponent of 1. So we just copy 4 over -2. That's my horizontal asymptote, which is -2. So -2. And hopefully you can see that the graph goes through this top section right here, like that. On the left side, I'm going to plug in a number that's a -2 to double check. If I plug in -2, if I plug it into my easy version, -1, -2 plus 3 over -2 plus 1. This gives us -1 times +1 over -1, and this gives us +1. Is that right? Oh, that's +1. Well, x is -2, y is +1. Is that right? I don't think that's right. Did I mess up someplace? 2, 2. If I plug in -2, right, -2, 4 times -2 plus 6, and -2 times -2 minus 2 is -8 plus 6 over, that's 4 minus 2 is 2. This becomes 4 minus 2. -2 over 2 is -1. Huh? I'm confusing myself here. That's -2 plus 1. -2 plus 1 is -1. And -2 plus 3 is +1 times the -1. Where did I mess up? I feel like I messed up someplace. The top. Oh my gosh. Mr. Co's an idiot. Anyone catch him? Thank you, Christian Jordan. Thank you, Christian. I messed up where I plotted this stupid dot. I messed up because the 0 is at negative 3, 0. So the dot should have went over here. Okay. Then how did I mess up over here? Negative 2 times negative 8 plus 6 is negative 2. And on the bottom, negative 2 is a positive 4. It's negative 1. And negative 2... How did I mess up on this right side then? If I plug in negative 2, negative 8 plus 6 is negative 2. Negative 2, that's positive 4 minus 2 is... positive 2. Negative 2 and negative 1. How come I got negative 1 here, but then I got 1 over here? How did I mess up here? At negative 3, it's 0. Okay. So I'm thinking I'm going to be over here. I messed up on some basic math someplace. I'm trying to figure out where I burned myself. Right? If I plug in negative 1 times negative 2 plus 3 over negative 2 plus 1. Oh, I think I messed up here. That's going to be negative 1 times 1. No, that's right. And this is going to be negative 1. That's positive 1. What? Okay, that one's right. Negative 2 plus 1, negative 2. Sorry, I'm trying to figure out how come... I think I'm messing up in my brain someplace. But when I plug in negative 2 here, if I plug in negative 2, 2 times 4 is 8, right? 8 minus 6, negative 8 plus 6 is negative 2. Negative 2 is positive 4 plus 2. Okay, why is it negative 1 all of a sudden? I don't... So my problem is, I'm not sure, I can't see through my messed upness right now. I plugged in negative 2 into this problem here, and it's giving me negative 1. But why is it giving me negative 1? But if I plug it over here... Oh, I see where I made my mistake. There should be a 2 here. Is that right? 2 times 2 is 4. Oh my goodness. I see my mistake. Oh my goodness. I misfactored it right at the beginning. That was not a 0. 2, and we're left 2x plus 3, and negative 2x minus 1. X plus 1. That's where I made my mistake. Gosh. The horizontal asymptote is still the same. Vertical asymptote is still the same. I just messed up on my root. My root is 2x plus 3 is equal to 0. Minus 3 minus 3. 2x equals to negative 3. Divide by 2 and divide by 2. X equals to negative 3 over 2. Which is, x is negative 1.5. Got it? So at negative 1.5, that's my root. So my root is negative 1.5. And we said our negative 2 would be negative 1. So our graph would look something like that. My goodness, it took me like 5 minutes to figure out that I misfactored it right at the beginning. Alright, so let's go ahead and be done with it. Okay, so what you're going to do, you're going to go ahead and graph the vertical. So we have to read it. It's a horizontal asymptote first. We have a horizontal asymptote we said at negative 2. Oh, darn it. So you have to move it around. So you have to pick a point where the horizontal asymptote are together. So we said our horizontal asymptote is negative 2, but our vertical asymptote here is, we said positive 1. Okay, that's what we said before. And then the next point is we have to put a point on the graph. And we said at 1.5. Uh-oh. That doesn't look good. Zero, negative 1.5. Nope. That's what. Okay. Let me try again. A negative. Oh, did I draw on the wrong side? The x. We said the root would be at positive negative 1. Darn it, negative 1 and negative 2. Here it goes. And 1.5. There you go. Sorry. To reiterate, our horizontal asymptote was negative 2. Our vertical asymptote is x equals to negative 1. And our 0 here, the easy number was 1.5, negative 1.5. Okay, let's do it again. This time, hopefully I won't make any more mistakes. Okay. So our vertical asymptote and horizontal asymptote is going to be y is equal to negative 1 because it's the same speed, x. So it's just a coefficient, 1 over negative 1. My vertical asymptote, looking at the bottom, negative x plus 2, make this go to 0. That's going to be x is positive 2, right? Negative 2 plus 2 is 0. And my vertical asymptote, sorry, we already did that. My root, x minus 4 is equal to 0. So when x equals to 4, we would have a root. So we have root at 4 comma 0. So we have everything we need. Let's go ahead and graph it. So our horizontal asymptote we said was negative 1, but our vertical asymptote is at positive 2. Okay? Horizontal asymptote is negative 1, vertical asymptote at positive 2. We also have a 0 at positive 4. That's your graph. Looking here, same idea. What's my vertical asymptote? What's my horizontal asymptote? And then graph a point. So vertical asymptote is, looking here, vertical asymptote would be positive 2 because negative 2 plus 2. Nope, it would be a negative 2. Negative x minus 2 is equal to 0. Plus 2 plus 2. Negative x equals to 2. X equals to negative 2. That's my vertical asymptote. Horizontal asymptote, take a look at the front. We have negative x and negative x. That becomes negative 1 over negative 1, which is 1. That's my horizontal asymptote because the exponents are the same. And we have a 0. Negative x plus 2 is equal to 0. If x equals to 2, we have a 0. So the root is 2 comma 0. Okay, let's go to graph it. So the root is going to be, vertical asymptote is going to be at negative 2, but my horizontal asymptote is going to be positive 1. Negative 2, positive 1. And then we had a 0 at, we said, positive 2. Okay, all right, we did it. Now let's jump to the next type of question. Next type of question here is you're going to pick the graph that best fits these possibilities. So I want you to make sure that you guys can see which of these graphs have would match. Now there's a couple of different options here. First thing, let's go take a look at the zeros. What are the zeros of the function? Looking on top, what would make x plus 1 go to 0? Negative 1. What would make x minus 2 go to 0? Positive 2. So we're looking for zeros at negative 1, positive 2. So negative 1, positive 2, that's a possibility. Oops. Negative 1, positive 2, that's a possibility. Negative 1, positive 2, nope, that the second one is not a possibility. Negative 1, positive 2, that is not a possibility. And negative 1, positive 2, this is also a possibility. So we have two possibilities to go. So of these options, would we be okay to say that the vertical asymptote is a problem? It's going to be negative 2 and positive 5. Negative 2, positive 5, yes, that has a vertical asymptote. And negative 2, positive 5, these also have the same vertical asymptotes. Now, we can see the horizontal asymptote, -2 or +2. If you look here, it's going to be 1 and 1 because they're both x squared. So it's going to be -2 times 1 is -2. My vertical asymptote on top looks like it's going to be at +2. Horizontal asymptote for this guy looks like it's going to be -2. Our answer is this guy down here. Right? So you're going to use the characteristics to figure out which graph is going to match. And that's it. That's a practice. You have 12 questions on this. This is leading us to being able to graph it by hand without using a calculator or anything. And that's really the skill. On the test, you guys will be asked to graph as many as you can using the skills that we're learning here and we're practicing here. Okay?